Welcome to another day of geometry proofs. Today we're going to talk about complementary, supplementary, and angle pairs. So first of all, let's go ahead and take a look at the warm-up. We have that BFC is 2x. We have CFD is 3y. BFA is y. And DFE is 4x. Make sure that you guys always label your diagram. I think sometimes you guys try to do this in your head and it doesn't always go so well. And then it says BF is perpendicular to DF. Okay. What does that mean? It means that is 90 degrees. So we have a system of equations that we can set up here. The first is that all the blue, not focusing on the red, all the blue creates a straight angle, which is a line. A straight angle adds up to 180 degrees. Okay? And then for the red, we have that those two angles, 2x plus 3y, equals 90 degrees. And we have a system of equations. So I'm going to multiply this bottom equation by -3. And that gives me -6x minus 9y equals -270. We add those two together and we get -5y to equal -90. Then we divide to get y by itself. And we get y to equal 18. Plug that back in to get x. So 2x plus 3 times 18 equals 90. So 2x plus 54 equals 90. 2x equals 36. So x equals 18 as well. Now, the big thing we have to remember is to still find the measure angle. Okay? So the measure angle is DFE. DFE is 4 times x. So measure of angle DFE is 4 times 18, which is 72 degrees. Okay, let's go ahead and get into some more definitions. So first of all, complementary angles are two angles that add up to 90 degrees. So if we change those into if-then statements, if angles have a sum of 9 degrees, then they are complementary, and then the converse, if angles are complementary, then the angles have a sum of 90 degrees. So here's two more to add to your list that you need to know. Supplementary angles, same thing. The definition, two angles that have a sum of 180 degrees. Just a reminder that supplementary and complementary angles do not have to be adjacent. Linear pairs do need to be adjacent. So again, we have our if-then statements. If angles have a sum of 180 degrees, then they are supplementary. And then if angles are supplementary, then then the angles have a sum of 180 degrees. Okay, go over to our definitions. We know that it's 90 degrees. We're trying to prove that they are complementary. So I know there were some questions on when you're supposed to use the definition versus the converse. The hypothesis has to be what you have. The conclusion is what you're trying to prove. I literally just had to pause this video for like 2 minutes because Rocky's been crying outside the door. All right, so like I was saying, we have the hypothesis needs to match what you know. The conclusion needs to match. Let's go to the next slide. So here's just some word problems that we're going to practice with. So it says the measure of one of two complementary angles. So first of all, let's identify that complementary is 90 degrees. Is 3 greater than twice the measure of the other. So the other is going to be x, and then the complement is 3 greater than twice that. So 3 greater than twice that. Okay, so we have x plus the other angle. Remember that two complementary angles add up to 90 degrees. So when you're doing this, you should have two angles. So we have 3x equals 87, x equals 29. So it says find the measure of each angle. Well, the other, which was blue, was 29 degrees. And then the red was 2 times 29 plus 3. That gives me 61 degrees. When you're done, double check your work that it adds up to 90 degrees, which it does. Okay. All right, next example says find the supplement of an angle. So first of all, supplement means we add up to 180 degrees. The measure is 1 is 60 less than 3 times the other. And then here's my other. So we have x plus 3x minus 60 equals 180. So we get 4x to be equal to 40. So x equals 60 degrees. So it says find the measure of the supplement of an angle. So we still need to find this part. So 3 times 60 minus 60 gives me 120 degrees. Again, check to make sure that those two angles are actually supplementary. Alrighty, let's get into a proof. So my proof, the given, always start with the given. So measure of angle RST equals 50 degrees. And measure of angle TSV equals 40 degrees. That was given to you, so you can go ahead and label that I in the diagram. Remember that the only thing you can label on the diagram is something that is given to you or something that you can prove. So we're trying to find out that angle RST is complementary to angle TSV. We know that angles are complementary if they add up to 90 degrees. So the first thing we have to do is show that these two angles add up to 90 degrees, and we can do that. So measure of angle RST plus the measure of angle TSV equals 90 degrees. And we just say that's by addition. You don't need to write the angle addition apostolate every time. You can just write addition. So if we go back up to our definitions that you're trying to prove. So in our example, we would say that angle RST is complementary to angle TSV because if two angles have a sum of 90 degrees, then they are complementary. Okay. All right, last page of notes. Vertical angles theorem. So the vertical angles theorem states basically just that vertical angles are congruent. So if angles are vertical angles, then they are congruent. So this this is another one of those definitions that you are going to want to know. Now for this one, we actually can't use the converse, because the converse would be if two angles are congruent, then they are vertical angles, and that's not true. So we only have the definition for this one. All right, so we're going to look at these angles, and we're going to talk about, are they a linear pair? Remember that a linear pair creates a line, makes a straight angle. Vertical angles has to be created by two lines that are continuous, and adjacent angles are right next to. So let's start with angle 1 and angle 2. So here's angle 1 is created with those two lines. Notice that angle 2 is created with the exact, same lines. So if angles are created by the same exact lines, we have vertical angles. Okay? Angles 2 and 3. So here's 2, here's 3. Those are right next to each other. So these are adjacent angles. 5 and 7. So be careful, 7 is this whole angle, and then 5. Notice that those two angles make a line, they make a straight angle, so they are a linear pair. 3 and 5. 3 and 5. These do not make anything. Okay? So some people confuse this with vertical angles. Notice that they are not created by the same lines. Okay, verticals have to make those V's. And then lastly, angle 7. So here's angle 7 and the angle created when you put 2 and 3 together. These are vertical angles again. Notice how you can clearly see the X. I don't have any wicked X's going on. All right, so it says, given 1 and 2 are complementary adjacent angles, draw the diagram of angle 1 and 2. So first, let's draw a diagram. Complementary means 90 degrees. It doesn't say that they're congruent, okay? It just says that they are complementary. So angle 1, angle 2, and I'm going to mark that this is 90 degrees. So if angle 1 is 4x plus 12, and angle 2 is 3x plus 8, solve for x and find the measure of both angles. Well, since they're complementary, they add up to 90 degrees. So we get 7x plus 20 equals 90. 7x equals 70. So x equals 10. Then we have to find the measure of each angle. So measure of angle 1, when we plug that in, we get 52 degrees. And then measure of angle 2 is 38 degrees. Again, at the end, check to make sure that they are truly supplementary. Alrighty, last example, and this one, this is going to be our longest proof, but that's okay. So, we know that the measure of angle 2 is 60 degrees. So this is 60. And angle 1 is supplementary to angle 4. Okay, so basically this means that they add up to 180 degrees. So let's go ahead and mark our given. Okay, so we somehow need to work with angles 1 and 3. Okay, well, something that we can see is that measure of angle 1 and 2 are going to be congruent. And the reason being is because vertical angles are congruent. And for this one, you guys don't have to write it out. you can just literally write vertical angles are congruent. So, if angles are congruent, then that means that the measure of angle 1 equals 60 degrees. Reason being, if angles are congruent, they have the same measure. Okay? So, we know the measure of angle 1 is 60 degrees. So our goal then is to show that the measure of angle 3 equals 60 degrees. So let's go to our other piece of given information. We know that the measure of angle 1 plus the measure of angle 4 equals 180 degrees. Why? Because if two angles are supplementary, then the sum equals 180. Okay. So can I find some information now about angle 4? I can, because we know the measure of angle 1 is 60. So measure of angle 4 equals 120. And we just say by subtraction. Okay, so I'm going to go back up to my diagram now and mark what I've proven. So I've proven that measure of angle 1 is 60 degrees. I've proven that measure of angle 4 is 120 degrees. Somehow, I need to prove that angle 3 is 60 degrees. Well, if you notice, angles 3 and 4 create a linear pair. What do we know about a linear pair? A linear pair adds up to 180 degrees. So, step 6. Angle 4 plus angle 3. And by the way, again, I think I said this in the last video, you can assume linear pairs. So if two angles form a linear pair, and are adjacent, they are adjacent and supplementary. Okay, so now we know that angle 4 plus angle 3 equals 180. And we know the measure of angle 4. The measure of angle 4 is 120. So step 7 is going to be that the measure of angle 3 equals 60 degrees because of subtraction. And voila! We now have what we intended. The measure of angle 1 is congruent to the measure of angle 3, because if two angles have the same measure, then they are congruent. Uh-oh. Of course, at the very end, then they are congruent. All right, that was a pretty involved proof. So if you guys have questions on this video, please ask me, okay? Thanks so much, you guys. I appreciate every time you listen to these videos, especially with my superb voice. I appreciate the time you take out to prepare yourself for this class. Thank you.